Hello, I am Vishnunandan, a student of second year electrical engineering, and today in this video I am going to explain how to make solar tracker on Tinkercad using Arduino. So the components used in this are one Arduino Uno R3, one breadboard, three solar cell, two multimeter, nine 1.5 volt battery, one regulator of 5 volt, one piezo, two micro servo, one relay SPDT, two potentiometer, one push button, and one LED RGB, four photoresistor and four resistor. So now I am going to explain some components role in the code. First, servo motors. Two servo motors are used for horizontal and vertical rotation. They are controlled to adjust the position based on input values from sensors. Second, LEDs. Three LEDs are used for visual feedback. The red LED indicates initialization, the green LED indicates movement, the blue LED indicates end position. Third, buzzer. Buzzer is used for audio feedback and it buzzes to indicate the end position. Push button. Not explicitly mentioned in the code, but it seems to be used to control a relay. The relay could be used to control external devices like lights or motors. Fifth, potentiometers. Two potentiometers are defined but not used explicitly in the provided code. They could be intended for controlling servo movements or other parameters. 6. Photoresistors. Four photoresistors are used to detect light levels in different directions. They are used in the telephoto cells function to determine the direction of movement based on the light intensity detected by each pair of sensors. 7. Analog inputs. Analog inputs are used to read values from sensors. These values are mapped to servo angles to control the position of servo motors. 8. Functions. Initialize. Initialize pins and components including LEDs, buzzer, and servo motors. Also, it provides visual and audio feedback during initialization. Test photocells. Read values from photoresistors to determine the direction of movement based on light intensity. Move servo. Control servo movements based on the direction determined by test photocells. Setup. Initializes serial communication and calls. Initialize loop. Continuously read sensor values, map them to servo angles, and call functions to control servo movement and provide feedback. Overall, the system appears to be a tracking mechanism that adjusts the position of servo motors based on the intensity of light detected by the photoresistor. The buzzer and LEDs provide feedback on the system's status. So now let's break down the code by line by line. So this is the code. So the first line, hashtag includes servo.h. This line includes the servo library, which allows control of servo motors. Now from line number 3rd to line number 6, this line defines the pin numbers for 4 photoresistors, presumably used for detecting light intensity in different directions. Now line number 7 and 8, these both lines define analog input pin for sensors. Then line number 9 to line number 10. This both line defines the pin for controlling horizontal and vertical rotation for servo motors. Now line number 11 and 12, they both line declare variables to store sensor readings. Line number 13, 14 and 15. This line defines pin for 3 LEDs. Line number 17 and 18. This line defines pin for 2 potentiometers, though they are not used in the provided code. Line number 20. Line number 20. This line defines a pin for controlling a relay. Now, if you come down a little bit in the code, line number 22. This line defines a pin for controlling a buzzer. Then line number 24 and 25. This both line declares servo objects for horizontal and vertical rotation. Now line number 27 and 28. These both lines initialize variables to store servo angle. Line number 30. This line defines the delay between servo and movements. Line number 32. This line initializes a variable to store the direction of movement. Line number 34. This line initializes a boolean variable to track the end position. The setup and loop functions are commonly used in Arduino sketches for initialization and main program execution, respectively. They are not used in any specific component's control. The remaining functions like move, servo, test photocells, and initialize are used to control the behavior of the system, including servo movement, photoresistor reading, and initialization of components. Now I will run the code. As you just as you can see, when I run the code, the LED glows from green to red, which indicates that the solar panel in now I am going to run the code. As you can see, when I run the code, the LED starts to glow from green to red. This is because the solar panel has detected solar rays. So thanks for watching the video.